Hello everyone. We'll start this VLSI interview preparation series with digital logic. This is part 1. We are starting with number systems, arithmetic and codes. Part 1. There are 4 types of number systems: binary, octal, decimal, and hexadecimal. Binary has base 2, octal has base 8, decimal has base 10, hexadecimal has base 16. I'll explain in the later part like what does this base represent. Initially, what is a number system? Consider this number 8540. This represents a quantity like this: 8 into 10 power 3 plus 5 into 10 power 2 plus 4 into 10 power 1 plus 0 into 10 power 0. Means if we add these quantities, we'll get this number. So every number can be represented by this, like by multiplying the coefficient with the power of that number system. These are called as coefficients, and the place it is sitting is called as power. For example, this is 0, this is 1, this is 2, this is 3. So, and this is representing the radix. So for example, radix or base, we can call it as radix or base. For example, consider a binary number system. There is this binary number which can be represented in this way, like coefficient multiplied with the base with power of the place. So 1 into, this is the base which is binary, 2 power 4. Similarly, plus 1 into 2 power 3 plus 0 into 2 power 2. 1 into 2 power 1 plus 0 into 2 power 0. So if it's an X number system, we can represent that number as summation of aj into x power j, where j is 0 to n minus 1. For example, if you consider the same example here, 0 to 4. Here there are 5 coefficients. If you count 1, 2, 3, 4, 5. So the summation will lie from 0 to n minus 1. N being the number of coefficients and a being the coefficient at place j. Here j is representing the place and x is the number system. If it is a binary, it will be 2. If it is a decimal, it will be 10. If it is octal, it will be 8. If it is hexadecimal, it will be 16. So each number can be represented in this way: summation of aj into x power j, where each term is explained here. And this coefficient lies between the 0 to r minus 1. If it is 2, it will be 0, 1. If it is, I actually written here, if it is octal, it is 0 to 7. If it is decimal, it is 0 to 9. If it is hexadecimal, it is 0 to 15. So if the numbers are more than 9, for example, in this case, it is more than 9, 10 to 15, these can be represented with these values with alphabets. 10 being A, 11 being B, 12 being C, 13 being D, 14 being E, 15 being F. So each number can be represented in this way, whereas coefficient lying between the index, the base value, means 0 to base minus 1. So we'll understand the conversions now. How to convert a one number in one number system to the other number system. Initially, we'll understand the conversion of all other number systems to decimal. It is a similar way that I mentioned before. We need to multiply the coefficient with the index to the power of that place. For example, if you consider this 1101 base 22 decimal base 10. So we need to convert this number into decimal number system. What we are doing is we are multiplying the coefficient with the uh, uh, with the with the base and its power, like the place. For example, if it is 1 into 2 power 3 plus 1 into 2 power 2, 0 into 2, 0 into 2 power 1, 1 into 2 power 0. So it is 8 plus 4 plus 1, it is 13 base 10. Similarly, you can convert uh, octal to decimal, hexadecimal to decimal in the same way, multiplying the coefficient with the base to the power of its place. Similarly, so this is the hint I have given. You can do this. Similarly, here multiply the coefficients with the base 16 and its power. Here in the place of a, we need to use 10. As I mentioned before, a represents 10. So we can have a doubt that what if the number is a non-integer. For example, if it is 1101.010, for the fraction part we need to start with minus 1, whereas we went from 0 to increasing, right? Like similarly, we need to start with minus 1, minus 2, minus 3. So this will be the place or power for this fraction part. So if we want to convert this binary into decimal, we need to do 1 into 2 power 3 plus 1 into 2 power 2 plus 0 into 2 power 1 plus 1 into 2 power 0 plus 0 into 2 power minus 1 plus 1 into 2 power minus 2 plus 0 into 2 power minus 3. If we do the result, we'll get the number represented in decimal. Similarly, you can do for the octal to decimal conversion, hexadecimal to octal to decimal and hexadecimal to decimal in the similar fashion, multiplying, considering this as minus 1, minus 2, minus 1 position and multiplying the coefficient with the base 8 to the power of its place. Where powers are these. Now we'll understand decimal to other number systems. When we converted other number systems to decimal, we had done multiplication. If you see here, when we convert decimal to other number systems, we need to do division with the radix. The radix we want to convert. For example, if it is 59 in decimal, what it will be in binary. So what we need to do is we need to do the division, like 2 to, for example 59, it is 2 2s are 4, 2 9s are 18 and the remainder is 1. Keep it there and again do the division and keep the remainder here. Again 2 7s are 14, keep the remainder here 0. 2 3s are 6, keep the remainder here 1. And 2 1s are 2, keep the remainder here. And while gathering, go from down to up and gather all those bits which will result in the binary number result. Do this until we get the result or remainder as 0 or 1. We need to do the division process till we get the result as remainder as 1 or 0 result, or and gather from from bottom to up. So again we may get a doubt like what if the number is not integer. So for example, I have given 59.425. This is decimal number. Actually, with the part before the integer part, we need to do in the same way, like do the division and gather the remainder bits from bottom to up. Whereas for the fraction part, we need to do the multiplication in the below mentioned way, like consider just the fraction part 0.425 into 2. Whatever number system we want to convert it to, we need to multiply it with the same base. So we had collected the fraction part 0.425 into 2 is equals to 0.85. Take this bit aside, only this bit aside, 0. Now 0.85 into 2 is equals to 1.7. Take this bit again aside. Now just take the fraction part every time and take the integer part this side. So 0.7 into 2 is equals to 1.4. Again take the integer part and take the fraction part here. 0.4 into 2, 0.8. Again take the integer part and fraction part here. Again 0.8 into 2 is equals to 1.6. Take the integer part here and fraction part here. 0.6 into 2 is equals to 1.2. Take the integer part here, fraction part here. We need to keep on doing this until we get a result as 0 here, or we feel that the number of bits we had gathered is sufficient or can give the accuracy of the number. So till that point we need to do. So from bottom to up, gather all these bits and keep after the fraction part. So if it's a octal or hexadecimal, means conversion from decimal to octal or conversion from decimal to hexadecimal, what we need to do is we need to divide the I had written here, we need to divide the that decimal number with 8 and collect those reminders from bottom to up. If it is fraction part, similarly we need to do take the fraction part away and multiply with 8, and as shown above, take the integer parts aside and multiply fraction parts only until we get the sufficient number of digits for octal. Similarly for hexadecimal. Consider this as a practice for you and do it. And the third case is octal and hexadecimal to binary conversion and vice versa. Generally, if we consider 8 is the octal base, 16 is the hexadecimal base. So this can be represented as 2 power 3 and 2 power 4. So whenever we want to convert the octal to binary, we need to represent the binary octal numbers in 3 binary numbers. For example, 4 can be represented as 100, 7 can be represented as 111. So this way we can convert octal to binary. If it is hexadecimal, we need to represent each digit in binary in 4 binary numbers. Like A is 1010, 9 is 1001. Similarly, while converting binary to octal or hexadecimal, we group the binary into group of 4 digits. For example, if you consider this binary number, we need to convert it into octal number. So while doing that, start from the right and start grouping 3 digits. If it is hexadecimal, we need to group 4 digits. If there are only not sufficient bits left, append zeros before, which is like 7, 7, 4, 5, 7, 6, whole this is 1. What if it's a fraction part? So we need to group from, start from a point, group from, start from right and go left. Here there are no sufficient bits, we need 3 bits, so append 2 zeros. And again start from fraction, for the fraction part, start from the point and group from here. Here if you see there is only 2 bits and 1 bit is not, I mean we need to group 3 bits, right? So append a 0 here, which will be 2. So similar way, I had given some questions here for 54.83 A3, which is hexadecimal, converting into binary, like converting each digit into 4 binary digits. Here I had given one more question, which is like grouping 3 bits, as I shown before how to group, convert it into octal. Here ends the number system and number system conversions. We'll see in the next video. Thank you.